Okay, good morning. Welcome to
Number 722.
Math 722. So over the course of last week, I saw this really interesting paper that was just about to be published on something called the Cantor set. Have you ever heard of the Cantor set before?
No.
No. Okay. I didn't think we had ever talked about it. So we're gonna talk about it today, and we're gonna see some fun and really surprising properties about the Cantor set, and then we're going to just come to understand about what they proved in this paper. Okay?
Alright.
So first, I'm going to give you a challenge problem. I want you to write 1/2 in base 3.
Well, let's see. Where would you start? So you'd start, so this would be the 1/3. 1/3, 1/9. And then so on.
Okay. So those are your digits.
Yep.
So you start with a 0, and then a point. Then you have the 1/3 digit, the 1/9, 1/27, 1/81. Okay.
So, see, so when you use the 1/3, you have to subtract it from 1/2 minus 1/3. So this is going to end up being a 1/6.
Okay.
So then that means you can use a 9. So you can use it once and once only. Or wait, can you use it more than once? No, you can only use it once.
All right.
So when you subtract 1/6 minus 1/9, so this would be 3/18 minus 2/18, so this would end up being 1/18.
Okay.
And then you can only use 27th once. And then, so I think it'll repeat like this because then 1/18 is going to be 3/54 and 27th is 2/54. So you find a common denominator. The number you're left with is 3 over it, and the number this digit is 2 over it.
Okay.
So it'll just go 1, 1, 1, 1, 1, 1, 1.
Okay. How could we check if that's true? That's a great conjecture.
Well, I've got a different way to see this. That maybe we could use to check this to make sure that 1/2 really is this.
Okay, great. I want your brother to finish, and then we'll see what you have to say.
Well, we can multiply it by 2.
Okay.
So, let's see. So we get 0.22222.
Uh-huh.
Going on forever.
Right.
And then this would equal 1.
How come?
Because, well, it should equal 1 because.
Oh, because it's one, if this is 1/2 and we multiply by 2, this ought to be 1. Okay.
And also, we've seen the same thing in base 10 where 0.9 repeating is 1.
Okay.
So it might be true for base 3, but I'm not sure.
Okay, that's a great argument. What were you going to say?
So my method was going sort of the opposite way.
Okay.
And sort of proving that this is 1, and then dividing it by 2 would give me this to be 1/2.
Oh, great. So you were going to start with this.
Yeah.
Okay. So how do you prove that's 1?
I'm just going to say that x equals 0.2 repeating.
All right.
This is all in base 3.
Okay.
Which means that 3x multiplying by 3 is the equivalent of multiplying by 10 in base 10.
Okay.
So it's 2.2 repeating.
All right.
Now we can subtract these and say that 2x equals 2. So x has to be 1.
Interesting.
Then you divide.
So this is 1, and then I can divide by 2 and get 0.1 repeating is 1/2.
Very nice. That's great work. So we have found that 1/2 in base 3 is 0.111111111.
Yeah.
Repeating. Okay, cool. Now we're going to talk about the counter stuff.
Alright.